Hi there, welcome to BaxEDM. Time for a new video, one that I have been wanting to make for a long time now. I'm going to update my wire EDM machine, in particular the water system. First a bit of retrospect. So here's my current wire EDM machine. I'm super happy with the machine mechanics and the arc generator. Everything works very well, and I'm using it to run production parts every single day. So the machine is perfect. The thing that's not perfect is what's below the desk, the water system. Now this thing has a lot of history into it. And it is still highly experimental, though functional. But it looks like a mess, and it has quite a few downsides. So some retrospect onto this setup. This setup is now almost 6 or 7 years old. And I initially started out with a single cart on a small aluminum welded frame that had 3 dish washing pumps that I used, and a small filter to get me going with EDM. That was the initial setup. Well, I quickly came to the realization that the dishwashing pumps weren't providing enough pressure and flow. So I had to swap those out. But the motors I used, or the pumps I used to swap out the dishwashing pumps, they did not fit anymore into the frame that I had already welded. So I had to put everything on the side. So now only one of the original dishwashing pumps still remains. That's that one, which I use to fill the tank and to perform the deionization. And here are the 2 other pumps that I use to replace the dishwashing pump. So here's a big centrifugal pump that I use for water cleaning. So it sucks in dirty water and it spits out the dirty water at pressure, forces it through these filters, turns it into clean water, and then goes into the clean water tank. Then there's the pump in the back, that one here. It sucks in clean water and it forces it at a high pressure 10 bar to the flushing nozzles in the machine. Yeah, so the pumps did not fit anymore, so I had to put them on the side, making it all very unorganized. Then I switched the initial water filter I used, which was one of these small filters. It quickly saturated with particulates. So I had to change the small filter I initially used with a big EDM filter, for which I made a custom housing. I still like it, that works nicely, but I wasn't able to fit this nicely, so it's just sitting here on top of it. That also something that I would like to change. But the big downsides of this setup are, firstly, it doesn't contain enough water. So if I want to fill my tank all the way to the top, or even 3/4, there's not enough water in this volume. The tank I initially used was a water waste tank from an RV. I purchased it new and then added some holes for all the lines to go, but it's just not enough. Also, the water kind of quickly evaporates, so I need to top it up frequently and then to redo the deionization. So that's all really frustrating. So that's number 1 problem. There's not enough water in the system. Second problem is that I'm still using this dishwashing pump to perform the deionization and to fill my tank, and it doesn't have enough flow. So deionization can take like up to 2 hours if I put a lot of new tap water in it, and filling my filling my tank can take like 5 minutes. So it works, but it's just way too slow, and it's annoying the hell out of me. And it has been annoying me now for 5 years or even more. So yeah, that needs to change. And switching to these quite high power centrifugal pumps there's another downside, which I didn't realize before, is that when using such a centrifugal pump, these have a low efficiency. So not only does it consume a fair amount of power, it also heats the water. Now normally in an open loop system, that's not really a problem, but in a closed loop system, it adds heat to the water in the closed loop system, so the water temperature will rise. And eventually, in long runs, making intricate parts, big parts that take a long time, the water heats up all the way up to a jacuzzi level, which is completely unacceptable because thermal expansion then ruins the accuracy of my part. So in order to counteract the inefficiency of that pump, I had to add a cooler. So this is like a fish tank cooler. So I had to add that, and of course there wasn't space, so added more lines and put the cooler on the side and things like that. So, you know, it works. It's just a total mess, and it's not nicely integrated, so this all has to go. This setup is not worthy of such a nice EDM machine. So finally, after all these years, it's time to take this experimental setup that has taught me many lessons and turn it into something super nice. And that is what this video is about. So I've made a new design, I'm going to build it. Let's first have a look at it in CAD. So in Fusion 360, I drew a general model of the new water system integrated with the EDM mechanics. Basically to make like a complete machine, everything integrated into a single card. Now this model holds almost all of the key components that I use, except for the big water pump that I use for deionization and filling the tank. For that pump I couldn't find the CAD model. And what this model also does not contain is all the plumbing pipes and hoses. So if you intend to clone this model, then you need to route the plumbing yourself. Now there are 3 pumps, 2 of which are shown in the model. Here is the first centrifugal pump. It sucks in dirty water from the dirty water tank and spits it out to the filters. Then there is the rotary vane pump, this one. That's used for the flush cups. And then there is a very big third pump here, not shown, that is used for deionization and for filling the work tank. So here's a drawer that you can pull out that has the keyboard and mouse. That's nice as a stowaway. Then this is the electrical cabinet that holds all electronics. So a lot of DIN rail mounted components. I will go into details later. Here's a placeholder for a monitor. And here's my wire spool holder. Well, I only drew the spool here. Still need to make a model of the whole spool holder. It's basically a super simple thing that just holds the spool in place with the rotary axis free, such that the machine can reel it off. Small wheels, these are high load wheels. The whole machine will have quite a bit of weight. So I think everything on top of the countertop here weighs about 100 kilos. And then this is an 80 liter tank, and this as well. So that's 160 kilos of water. And then the whole frame, so yeah, might actually weigh somewhere about 400 kilos, is my guesstimate. So you need some pretty sturdy wheels to carry that load. It's mainly that the water weighs a lot and it contains a lot of water. So yeah, so that's basically a tour of the integrated card. So all key components that I used are given in a list that is shared on BaxEDM.com. I will share a link to the list below, so that you can see for each of these components where I got them, what its manufacturer is, what its type number is. And together with the CAD model, that should allow you to easily clone this machine. Okay, so enough for the general model. Let's dive into the build. So for the water tanks, I was looking for a tank that was easy to open from the side to get access to the internals for cleaning. I also was looking for a tank that wasn't all that expensive. Something that would fit my design nicely. So I found these square tanks. Well, they're not tanks actually, they're livestock feed drums. But they have a watertight seal in the cap. So I decided to fill a drum up with water all the way to the rim, close it off, and then put it on its side and leave it for a couple of days just to see if there were any leaks, which there weren't. So I think this type of container can be used for storing water efficiently, and then it allows for easy access to the inside from the side. So the plastic is a bit thin, so the sides bulge a bit, but the steel frame will support in that to prevent the bulging from getting too bad. So I think this is a nice and cost-effective solution. So 100 kilograms of steel arrived today. So I guess it's time to start welding and to start making the frame for my new water system. Here's the frame build in progress. Starting to look like something. Still need cross members, a lot of stuff. So the welding work is done. Now I'm painting everything. So nice color of blue. Turning out nicely. Okay, small time jump, and here we are. The frame has been finished and painted. I also added quality plywood sheets and covered them in 2-component epoxy to make them watertight, because it's hard to prevent all spills. You will spill some water. So yeah, it's turning out nicely. Let's have a look around here. So I'm planning to connect the water tanks with these PVC pressure fittings. I already drilled the holes through one of the tanks and through the plywood. And yeah, that allows me to hook them up, which is the next chore. And another time jump. I added the drawer feature for stowaway of the mouse and keyboard. That's convenient. I also added 4 float switches for measuring high and low water levels in each tank. And I added 2 out of the 3 pumps and 2 electrical valves and some hoses. And here on the right side we can see the plumbing and water filters that I use for the deionization resin. Here in the back is the centrifugal vane pump. Yeah, it's about halfway done, I should say. Well, at least for the water system, not for the electronics. Okay, let's go through the main components of the water system. I will have a link in the description that points to a web page that shows the very detailed information about all these parts. I'm just going through the numbers now and giving an overview. So for water filtering, I have 3 filters. There's a big custom enclosure that I made for the EDM filter. That's 10 micrometers. Then I have a 10-inch water filter housing with a filter cartridge that filters up to 5 micrometer particles. Then I have the same housing with a filter that does 1 micrometer particles. And these 3 filters will be connected in series. And next to water filtering, there's also water deionization. I've already fitted those filters. The deionization filters also reside in 10-inch standard water filter housings. So you get the cartridge, you fill it up with your own resin, and then you put it in the housing. And I have 2 of these in series. So that's water filtering and water deionization. Then there are 3 water pumps. A small one, a big one, and a really nice one here. So let's start out with the small one. I'm using this one to suck in dirty water and then push it out through the 3 filters in series. This small pump is half a horsepower, so about half a kilowatt. It displaces 2.2 cubic meters per hour in water volume at a maximum pressure of 3.2 bars. Then there's this big one. It's 1.3 horsepower, about 1.5 kilowatts. It displaces 4.8 cubic meters per hour at a maximum pressure of 4.8 bars. And this big one is used to fill the water tank, the EDM water tank, but also to push the water through the deionization filters so that the deionization can occur quickly. So I either do one or the other, so filling the tank or performing the deionization. And for that you should be able to switch. So I use 2 electrically controlled valves. These are Rainbird valves. So one is for filling the tank and the other is for deionization. This is all in the making. Everything still needs to be hooked up and connected. All the piping and things routed, so that's all in progress. So that's the big pump, and then this pump here is for the actual flushing of your workpiece. So these 2 lines go to the so one line is the input, the other line is the output, and the output is forked into 2 lines which go to the upper and lower flushing heads. So this, instead of being a centrifugal pump, which I used in my previous setup, this one is not centrifugal but a rotary vane pump. It's a lot more expensive. For the price of this pump you can basically buy the rest. So I bought a kit of the pump head, this bracket, the motor, and this frequency converter, and the kit was $600. But this pump, being a rotary vane pump, I can achieve higher pressures, and it has a higher efficiency, so it won't heat my water, and therefore I can get rid of the big cooler that I used to use. So really looking forward to start using this one. It will make my setup a lot simpler, and I can get higher pressure, so that's really nice. Those are the key components of the water system. So here's a small selection of the parts that I will be using to connect everything together in my water system. I really like this PVC pressure fitting system. These come in all sorts of different types and sizes. For most of my system I will be using 25 millimeter inside diameter, so roughly an inch. Except for the water drain tubes, I will use 32 millimeter for that, to make sure that the gravity fed drain drains quick enough. So these PVC pressure fittings, there are a lot of different types. So I'm using here mostly our knees, T-joints, these things, hose pillars, couplings. These are really convenient. So whenever you make a rigid piping system and afterwards you need to disconnect things, and then you use these couplings. For instance, I use these couplings to connect my filter such that later on, when everything's glued together, I can still remove the filter. I have non-return valves here. I use a couple of those. Manually operated valves in order to drain the tank when needed. These are tank couplings. A lot of different parts. Also a lot of different adapters. So I use, for instance, this 3/4 inch thread to 25mm adapter for my filters. This here is my HANA water connectivity sensor, which I screwed into one of these adapter rings, and then I glued it into a T-section, and I will mount this in the water line going to the clean water tank. That allows me to measure the connectivity. So this hose has quite a limited bend radius, so whenever you need to make tight turns, you use the knees, and whenever you have longer sections that are just curved slightly, I use the hose. And yeah, that's how I connect everything together. Okay, so another time jump, and my machine has finished. So it was quite a bit of work, a couple of weeks, and I initially didn't intend to make or to cover it on YouTube. The amount of work involved, I could have easily done like a 10-part YouTube video series, but I have something else in mind for a really nice YouTube video that I'm currently working on. And while I was working on that, I needed to update my machine because there were a few points that were annoying me too much. So in the end, I decided to make a video. Now, the machine is done. Let me guide you through it so I can show all the work that I've done. All right, so I started out with the welded steel frame, then added all the plumbing. So there are 3 pumps, 2 valves, 3 filters, and 2 deionization filters. Most of the lines are high pressure PVC, and then a few lines which are low pressure. I use just standard hose for that. Now I can drain the tanks when needed with this drain. In the back here you can see the wire spool holder and my collecting bucket that holds the wire snipper, wire clipper, wire chopper I should say. So here all the chopped wire ends up. On this side there's the new BX18 arc generator. I did not do a permanent installation for this with bolts running through the front face because I need to test a lot of arc generators in this system. So I'm continuously swapping arc generators out, testing them. So for me this is the most convenient thing. I just added like a shelf that has ventilation so that I can easily swap them out. Here's the keyboard again. This is a really nice feature. And I made a really nice control panel. So this control panel controls the upper and lower flush cup pressure. It controls the 3 different pumps and the valves. And I can choose to turn the pump off or on manually, or set it to auto, in which case the computer has control over the pumps. My G-code can control the pumps. Then there's a main switch that turns on the contactor, and then the single switch turns everything on. So the mini PC, the screen, the motor drives, the arc generator, everything, the whole machine turns on with a single switch, so that's really nice. There's the water deionization controller, which I can set to auto, and then it controls the water conductivity level. So here's my existing machine. I did not change it. Actually I made 2 very small changes. First change is that I added an additional hole, which is now capped with a plug, that I can use to drain the water out the side instead of back into the system. So as you can see, everything is pristine now, super clean, while before it was like totally crapped up with EDM crud. So I wanted to clean everything, and for that you need a special cleaning agent, which is based on phosphoric acid. And then when all that stuff is inside here, you want to rinse the acid away without getting the acid in your closed loop water system. And for that, you need an additional drain. So only for cleaning, I use that additional drain plug. And there was one wheel, this little wheel. I changed it by increasing the diameter a bit, because with the former wheel, it was slightly rubbing here. Now with the bigger wheel, that rubbing problem is gone. So those are the only changes I made there. Nice big screen. This is the electronics cabinet. I will cover that in a moment. So yeah, everything's on one integrated card. The only thing that you need is to plug in power, and then the whole machine can run by itself. What I really like about this, compared to my previous setup, is that it's on wheels. I can push it around, I can walk around it when I need to service it, or I can place it somewhere else if it's in the way. That saves me a lot of space, and I don't have a lot of space in this shop, so that's really valuable for me. Okay, time to give a small demo. So, power in. First, let's fill the tank. And before I do, a small note. The water flow rate is really high. So I used to fill my tank in like 5 minutes. Now I can fill the tank in just 30 seconds. Not all the way up to the top, but up to the machining level in 30 seconds. And that's a lot of flow. If you were to just get a hose and get that amount of flow just out of the hose into the tank, the water will splash everywhere. So I made a special nozzle, this one here, that distributes the flow in such a way that even at that high flow rate, it does not cause any splashing. So I can fill the tank without water getting everywhere. So yeah, that's a nice feature. So let's turn the machine on. So this turns on all the power. The computer is booting now. So I can use my computer when Linux is finished booting. So it runs on LinuxCNC. So let's fill the water tank. I'll do it manually now. Normally I could also fill the tank with my G-code, but I'll fill it manually, then you can see how fast it fills. that's like not even half a minute and I'm already up to machining level. So this is super nice. It used to annoy me a lot that when I had to do a quick job, every time emptying and filling the tank took a long time, but now it's super fast. So here's my water conductivity level, 22.9 microsiemens at the moment. Yeah, I can start flushing, for instance. So here's the flushing. It's now set to auto. For computer control, I can set it to manual. Now the pump ramps up. I can control the water pressure here. As you can see, this is the pressure through the flush cup. So here are my level meters. So whenever red goes on, I know the water level in the tank is too high. And then there's a green light which shows the lower level. If the green light is on, then the low level is high enough to suck water from the tank in order to pump it around. If the green light is off, then the level is too low for the pump to suck. So this is for the dirty water tank, this is for the clean water tank. So when I start draining my dirty water, this green light goes on because the level rises. And then the pump goes on and the filtering process starts. So let me show you here. This is something I still need to automate. So I have a drain here, and the height of the drain determines the tank water level. So I want to have something that is adjustable and something that I can automate, because I reserved one switch to drain the tank manually or automatically. So I need to make a controllable mechanism for draining here. That's not finished yet. So at the moment I have to make my fingers wet. I don't like it, but it's I will change that later. I pull the plug, everything flushes, and then the pump will start. As you can hear, the pump is now starting. Green light's on. So now all the water will drain from the tank into the dirty water tank, and then it gets filtered and pushed into the clean water tank. And draining is pretty quick. Takes slightly longer than filling, about half a minute. So now this one will turn off again, and then we're done. Yep, we're done. So that's filling and draining. Okay, let's have a look at the electronics cabinet. So here's the cabinet. As you can see, I added ventilation. So here it sucks in air with a fan, and here it spits out the air. I initially did not have the fan and the power supplies got too hot. I added nice LED lighting. In the door here I made a 3D printed thing to store the documentation that comes with the parts. And here's my water conductivity calibration probe that I use once in a while. Now here's the control cabinet. I labeled everything. So here's the XY motor supply, the supply for the wire servos, supply for the PC. So this mini PC here, it comes with a power adapter. It's like a wall hog. I don't like that. So instead I use the 12 volt adapter, or a 12 volt DIN rail supply. That's this one. Then I have a 12 volt peripheral supply. What that does is it powers the LED lighting, the fans, the wire chopper motor, everything that's 12 volt. And there is a small logic power supply unit. Then I have my EtherCAT motor drives. This one's for the X-axis, this one's for the Y-axis. I still have some space left for a third axis, a rotation axis that I will add later in the future. Here's the speed controller for the flushing pump. The rotary vane flushing pump. I keep forgetting that name. I have a timer here that I use for the dirty water pump. This one is quite useful. So there's a float switch in the tank, and whenever the pump turns on or off, there's like a wave in the tank which jitters the float switch. So I use this timer to get rid of that jitter and make the pump on and off turning behavior a lot nicer. Then there are two solid state relays, one for the water cleaning pump and one for the fill/deionization pump. Here's the main contactor to turn everything on or off, and the rest is just a bunch of wires. So there are not many components. It's just this row of power supplies, two motor drives, and some solid state relays. These are also solid state relays. One turns on the wire chopper motor, and the other solid state relay I use to have software control over this thing, turning it on or off. So everything, the whole machine, electronics, apart from the arc generator, all electronics of the machine, that's it, what you're looking at here. So yeah, it's quite some wiring, but the number of components is not that high. This is not really complex to build. I'll make a schematic of this so that you can copy it. Okay, so now you have seen my new wire EDM machine. And for those of you who want to build such a machine yourself, I have documented everything. So starting with the CAD model of the machine mechanics itself, I have a detailed model of that. And then there's a CAD model of the overall machine, so the machine mechanics integrated with the water tanks and the water pumps and things like that. The CAD model I've shown in this video. Then I've made a key component list. So a long list of all the components that I used, where I got them, what their type number is and things like that. I've also created a software installation instruction that allows you to do the software install yourself on a new PC. So the installation of LinuxCNC and the BaxEDM related software components. And I've made a wiring diagram for the control cabinet. That one's not identical to the control cabinet I'm using. That wire diagram only does the very basic stuff to get everything up and running. And you can expand on that if you want to add features. But the basic wiregram is more than enough to just get you going. So all that information is shared for free on BaxEDM.com. And yeah, that should enable you to clone my machine and make something beautiful. Okay, I want to close off this video with a couple of small remarks, things that I found out during my build. So the first thing is that I'm using these Rainbird water valves. And those are intended to be used or to be driven with 24 volts AC. And that's not really convenient in the control cabinet, an AC voltage. And anyway, if you run them with 24 volts AC, they're
they're noisy. They make like a buzzing sound, which is super annoying. And 24 volts AC is inconvenient in a electrical control cabinet. So what you could do instead is run them with 12 volt DC. Do not run them with 24 volts DC, because then the valves will burn. But you can run them with 12 volts DC, which is what I'm doing. And then I can use the same 12 volt peripheral supply that is used to drive the fans and such for the valves as well. So that's really convenient. Then I got the centrifugal vane pump, of which the motor cools itself. So there's a fan blade to the motor axis that sucks in air, but only if the motor RPM is above a certain level. And in the EDM application, the pressure is really high, but the flow is really low, and the motor RPM is quite low, while the pressure is high. So the motor has to deliver a fair amount of power at a low RPM. And I ran it for a while and it got too hot because the RPM was too low to provide sufficient air cooling. So what I did is I took off the original fan blade from the motor shaft, and I 3D printed an adapter to fit a standard 12 volt fan to the motor, such that at all speeds it gets maximum air cooling, and then the problem was resolved. And the very last bit I wanted to mention, the first time I assembled my complete water system and tried it out, it was leaking everywhere. It turns out that using Teflon tape to seal threaded pressurized interfaces is a bad idea. I always thought that was a good idea, but Teflon tape actually does not seal that well. So it took me a while to figure out how to get these high pressure water lines completely tight. So they were almost tight, but they were dripping once in a while, which is super annoying. But for those connections, so for threaded high pressure water connections, do not use Teflon tape. Instead, use something that's called fiber seal. So this is tape that has fibers inside, and when the fibers absorb water, they expand, and then they really make a watertight seal for high pressure fittings. So I was unaware of that, and it took me a while to get rid of all the leaks, but this stuff was the magic solution. So I just wanted to share that as a very last point, and that's it for this video, and see you next time.